Hello, my name is Evan Schwartz, and we're going to take a look at BattleCry's memory profile. So let me go ahead and get this moving. And I'm going to try to do what we did last time, is I'm going to do a picture-in-picture. So bear with me as I'm going to be holding my iPhone, recording my Android tablet, so that we can see what's going on. So at this point, we're at the login screen. The critical, and I'll do a quick pause here. The critical piece that we're going to just focus on, because this is going to be the telling piece for optimization on the memory profile, is use total memory. We'll find that the texture area is a big one. So one of the things that I ran into in milestone 9, and we'll just go ahead and let this continue to record and play, was that the newest mechanic where we visualize the battle cry, it would just spun up because of all of the processing and variables and objects behind it that had to be instantiated, shot the memory up. It was 100 megabytes worth of stuff for every time you listened to a battle cry. It was just ridiculous, the sheer amount of memory that the processing and all the storage and temp storage and swapping took. So after a lot of research, what I discovered was that the garbage collection, the one that you would typically expect to see in .NET, doesn't really apply to the monobehavior objects. So in this case, as we're looking at it, it normalizes at about 93 megabytes, 66 textures, so not a lot going on here on the login screen. Not a lot of changing, even though I flipped the panels and turned things on. So everything here appears to be about the same. The asset loads, clips, all of that stuff gets preloaded on the scene, so that pretty much stays static. But once these objects were being instantiated, like a prefab, and we were destroying the objects, they were never freeing off the heap. Now, the default stance for Unity was to create a fat heap. So if you go to 100 megabytes, it stays at 100 megabytes, it frees the stuff underneath it, and you can just keep reusing that memory, and it's just more efficient than having to allocate more heap memory if I can just work within the maximum heap size. And generally speaking, that would be okay, except for the fact that it never freed it up, right? So it still held references to all that memory, so when I would create another battle cry, boom, another 100 megabytes would kick in, another 100 megabytes, and it just kept growing and growing and growing and growing until eventually it crashed the system. Well, on this, so we're looking at the active game list right now, and I'm going to try to let it play. I'm holding my phone while using the mouse, so bear with me. We're at about 157-ish megabytes. Well, when I started running the profiler on these lists, because I'm creating these textures, right? These are dynamic textures based on what the map looks like. I expected that, my memory would go up and down, so I jump over here to the new, where there isn't anything in the list, and I'm at 156 megabytes. That feels right. And my textures were 160. But before the change, when I would go back, my memory would shoot up. It would actually go higher, never resolve, never settle back down to what I expected to settle down to, and my textures would shoot up by, like, however many I have in this list, 40, 50 items in the list. And I would never normalize. I would never get to a point where it wouldn't constantly be growing. So we're going to have, the plus or minus a few megabytes as I've got music in the background, things that are adjusting memory. So we're going to flip back. We're going to go to new. We're going to see it play, see if it drops down a little bit. And you'll see it tip back down. None of my main stats alter, right? And it seems to be holding steady. Let's go back to active. And I get a little bit of, this is basically calling out to the API and doing all that stuff. And I'm bumping back up here to 170. So I'm eating a little bit of memory on each flip. So let's do it a couple times and see if I ever get that memory back. Let's go over here to friends. Alright, so the memory went down a little bit. That's good. So we're back down to 162. And I'm on a list. So let's go to the high scores. See, that's a pretty big list. What does it look like? We're at 161. That's good. So we know that our list that's generating these dynamic textures is causing some consumption of space. Let's go back to the new, see if we get back to our baseline. So we're still hovering around the 161, and our texture count isn't going up, which is right now, from a mechanics standpoint, is the key critical component that I'm watching, because before I added in the garbage collection specific to Unity, and we'll take a look at that in the code, that number just kept going up and up and up. So every time I would switch back here to the active panel, it would regenerate all of these textures, right? And it never freed up the textures before. So yeah, we jumped up there in memory. That feels right. But our texture count and our memory around textures has not gone up. So that is exactly the behavior that we're looking for. I don't need to see this keep continuously going up. So the thought that Unity would properly manage and free up memory, it's a little squirrely, right? So we ended up having to put in some code to force it to free up any unreferenced material. So as we start to go to the list, does our memory drop back down? Yes, it does. That's good. Right? We go to other lists based on items, bump back up. Let's go back to our friend list. So now we're in a completely different list structure. We're back down to 160, so that feels good. So we're seeing memory go up and down based on utilization. Let's see what the credit screen looks like. Still hover around the 160, and again, none of my critical asset numbers are changing significantly. Okay, so that looks pretty solid, and we're still hovering around. I'm not seeing my memory just go up and up and up and up and up, and that was the behavior I was seeing before we added that garbage collection. Again, when we take a look at the code, we'll be able to see how that works. And just on the active list, I hover around the 174, 175, give or take, depending on how the page memory file works. So that feels like that's going up and down pretty nicely for me, and I'm in a much better space. So while it wasn't going up a lot, what I was seeing on the active list was the base memory creeping up to the tune of roughly 2 to 3 megabytes every single time I refreshed it, right? And it never freed it up, never. So you can imagine at some point the system would run out of memory. Now at 2 megabytes a pop, most users would probably never see it. But the reality is I don't really have a lot of limits. What if I had 100 active games that I was playing? Well, now that's a much more significant number that I have to deal with. So let's take this, let's boot it back up, see if we get around to our 175. Yeah, so we're hovering around on 175 now that we're back at the active list. So again, that's feeling like I'm not seeing any major moves here with my assets. I'm not seeing this texture just constantly go up. So now let's go into a game. Alright, so we're a lot more memory. Our texture number has changed quite a bit, and this is a new map, but we'll just move around, see if we're seeing anything change. We seem to be pretty static here. Let's go ahead and show the dwarf, not the dwarf, but the hero shop, and see if we can see any major changes there. It bumped up in memory a little bit, but we didn't see, again, any of our assets or textures just start to climb, right? So I don't see any kind of a race condition. Let's go over here to my flaming. I got a little money. Let's go ahead and buy. So we've got a little memory difference there, not much. So we're staying pretty static. Let's go back to the map. Try to keep this going while I try to do a combat here. So let's set trying to keep all my displays going at one time here. Sorry. So I'm still in the ballpark, not seeing too much in the way of climbing. A little bit of a bump, which I would expect from adding some more graphics visually to the screen. Alright, so I'm gonna let this slide over here to the right and we'll pick it back up as I do my attack. Raw! 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 Okay, so we're seeing as the process really escalates for the battle cry, and then boom, it drops back down. So that's good. That makes me feel good. And again, we had to do the same thing. We had to do the same thing with the battle cry, is force that resource collection, that garbage collection on there. And I'm not sure that that's a well-known concept with Unity, right? Especially living in the .NET world. I strongly expected that Unity would clean up after itself, right? Alright, so we notice that our memory is kind of bumped up a little bit, and our texture stayed the same, so that's good. But what happened there is I've created a whole bunch of instantiated objects, but I'm not using the little resource on these X's like I am the other things where you saw the memory drop back down. So we have a bump up and we're never coming back down. So this keeps speaking to the fact that anytime I instantiate an object, I'm not seeing the memory free up. But what's important here is the memory freeing up, is Unity properly using it as a heap, or is it going to keep climbing it? So I don't have an opportunity to really test this for multiple combats, but the only way to really test that would be to do multiple combats. So let's go back to our games list and see if we can find a game where I've got multiple pieces of land that I go in. See, this is a good one here. So I'm going to pick that guy. Pick that guy. They already go. Okay. And again, I apologize, it's hard to look around. So we're looking at a baseline of about 275 right now. At this point, 146 textures, so that's similar to what we saw before. So let's do an attack. And bear with me as I try to wrap around here. Raw! 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 Okay, let's get back over to here. So yeah, our memory is shooting up as we're showing this thing. Look at 200 megabytes, and then boom, after it disappears, back down to the 248. So that's nice, and that's using the resource garbage collection for Unity. But now let's do combat here and see if this rises back up to the 260. So we're at the 265. Let's see if it ever comes back down. Let's close this. Alright, we see a dip. We're at 254. That's not too bad. Now let's do a second combat here. Let's circle around. I'm going to do that. It's more challenging trying to, it's like looking in the mirror. Alright, we're baseline is 255. So we're still a little higher than we were. Let's do an attack. Raw! 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 Okay, let's get it back up here so we can watch it. And there it goes. It shoots up. It shoots up. It's eating up all this memory. And then the resource allocation, it's 248. So it's dropped back down again. Alright, so let's do our combat. Alright, we're seeing it bump back up because I'm creating all those X's. And let's see where we end up, is right about the 254, 255. Alright, so I did 2 combats back to back and I leveled out about the same place. So that does speak to that maybe these X's are doing what Unity is expecting, which is to grow the heap and then hold that heap combat after combat. And my, my resource deallocation, my garbage collection for Unity is freeing up memory, and then I'm working my way back up to that new benchmark. So what's happening with the the data source items in my active list and what's happening with my BattleCry instantiated object that makes it where I have to force the deallocation. So one of the things I've noticed, and this is sort of empirical, I'm not really sure, I'd have to run some prototypes or tests to kind of prove this out. But the difference between the X's that eat up memory, become a fat point, and then I can still live within that memory space, it's a high watermark. That's different than my list items and different than my BattleCry that balloons up, that forces me to deallocate them to get my memory back, is within that object's code. I am creating a bunch of dynamic .NET objects. I'm creating arrays. I'm creating new textures. I'm creating stuff within the context of that object. And what I'm concerned about is that because within the context of the object, I'm instantiating new textures. I'm not using the instantiate. I'm just creating the new construct to instantiate a new object of some kind within the context of that mono behavior, that maybe Unity doesn't know about it, and because the garbage collection of .NET doesn't know about it, those subcomponents, after I destroy the object, never get free. And that's really that'd be a bad bug, in my humble opinion, for Unity at large. But the good news is there's ways to compensate for that, which is what I'll show you next. So let's go ahead and in this turn, we'll go back out to the list. So there's another point I want to make based on the memory profile, is that on the loading and unloading of scenes, it's like a complete reset, right? It's a do-over. So when I was looking at some best practices, there were some arguments for put everything in one scene and then use visibility on panels to control. Don't create a whole bunch of scenes. Well, now I'm kind of backpedaling on that, because the way that Unity is managing its memory, I get a natural reset as I change from scene to scene to scene. So if I wasn't very careful with the way that I was allocating memory and deallocating it, switching from scene to scene would be the only way for me to kind of clear out a growing stack, which by any definition would be a heap leak. I mean, every time I allocate something, if the garbage collection doesn't come in and clean it up ever, and it doesn't seem to, that's a heap leak. That's a race condition where I'm just consuming memory, and just because the BattleCries, these things are so much memory, right? And we'll see this, boom, 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 build, 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 and then that's me forcing the allocation, the free up of that memory. With that much buildup, and as you can see, I mean, we're almost at copping out at double the memory, so it's like 150 megabytes every time I do one of those things. It wouldn't take long to reach the 2 gigabyte limit of the device on at least on my iPhone. Androids may have a lot more memory they can play with depending on your device, and then the system just crashes, right? On the iOS, it just exits the system. So unless you know how to read the Xcode debugger, it just exits. What are you going to do, right? So from a profile standpoint, those were the big gotchas, and the ability to free up and release those resources and make sure that these assets that I'm tracking down here, the textures, meshes, materials, all that stuff, becomes relatively constant. I'm not seeing it grow. And again, on this active list, because I'm dynamically creating the map textures, I just saw this grow, 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 and never release. So let's take a look. Let's go ahead and stop this, and let's dig into the code so we can see what we had to do. And BattleCry Cloud. So we showed this off at the end of milestone 9, but this GC is meant to do the garbage collection of the .NET. Now, strangely, I would expect, standard array allocation to be handled by garbage collection. For some reason, since they're in the context of a mono behavior, garbage collection never touches it. I'm still putting it in there, just in case, but the garbage collection alone didn't get it done. But again, like I said, I'm still a little mystified on how Unity is managing its memory at this point. So it's one of those things, better safe than sorry. And in this context, the cost to the operation at that particular juncture is not significant versus the gains of not running out of memory. But this is the magic. This is where Unity is basically unload any unused assets, and it will completely deallocate all of this stuff for me, and that gives me back my memory. Now, to make that work in the load active, the loading, and all of my lists use the same thing. So all the loads, we've seen that time and time again. So at the very beginning of the list, I iterate over what would be in the list, I destroy it, and then rebuild out the list and reinstantiate everything. So everything is being rebuilt every time you go to the list based on the data that comes in. I'm not trying to cache or reuse these objects. I could, but that's going to overcomplicate the code, in my opinion, to try to reuse some of these objects and refill this stuff. You know, if it got down to it, that might be a way to offset it, is just here's 100 list items. I'm not going to have any more than that, manage visibility, and as I iterate, I'm just updating their values. But from my perspective, just kill what's there and reinstantiate it doesn't cost me that much from a processing standpoint. But when I realized how much it was costing me from a memory standpoint, you know, I started to second guess that architecture. And so what I ended up doing is, after the destroy, I'm essentially calling this to deallocate these destroyed objects so that the unload can kick in and start to refree that up. And what that ultimately did is that stopped as you were navigating from list to list, and every time you go back to the active list, a certain amount of memory and new textures were created that were never freed up. I was kind of floored by it. I mean, I've used Unity in a variety of other projects, and I didn't even realize this was a problem before. It wasn't obvious enough to me, and I probably would have missed it had I not done the BattleCry cloud visualizing, which was, you know, here's 150 megabytes and a whole bunch of resources that are allocated that made it in my face, right? You know, 1 or 2 megabyte difference on the memories that floated around, I probably wouldn't have noticed it. But that sort of opened up this opportunity here to make sure that these lists are cleaned up, because again, you know, I got quite a few here in this list, probably more than what an average player would have. But one of the asks that haven't made it into the game yet is for a list to have an auto refresh. So now imagine that, even these lists here, just sitting here, and I've got this sitting on my desk, auto refreshing, auto refreshing, auto refreshing. I can imagine the bug report now. You know, every once in a while it's sitting on my desk and it just crashes. Well, wow, how are you gonna solve that, right? So this was a good find, and this is, I'm never gonna forget this, right? So this is gonna be, to me, the best case at managing memory. From a resource standpoint, it doesn't seem to consume a lot, but man, it really frees up memory when memory starts to get tight. And on that replay of the audio, that's a place where I could easily get resources ate up. And again, it was after 10 or 15 of those, boom, crashed the whole thing. Once I hit the 2 gig limit on my iPhone, boom, it just crashed. All right, so that ultimately is some enhancements we did for managing memory and how we tracked the memory profile on BattleCry. Everything else was very consistent from scene to scene. Again, right now it's just a hypothesis of mine that if I'm allocating large objects in the context of an instantiated object, that I run into this problem, because I only ran into it in 2 places, which is here, in which case these instantiated objects were creating and allocating stuff within them. Where's my set active data item? And that's where it's building out the texture, the watermark, creating of the hex. So there's a lot of allocation of new textures, and basically right here, this guy, on each one of those is being allocated. And of course, it's also not only allocating that, but it's allocating a texture, which is the overlay, which is the adding of the watermark. So it's kind of a double down for each one of those. So anytime I have this scenario where I've instantiated an object and within it I'm allocating you know, large color blocks, I'm allocating textures, I'm allocating large arrays, it seems like the prefab that was instantiated, even after it's destroyed, never frees up the memory without being forced to do it. So going back over the Unity's best practices on some of the ways to manage memory, Of course, it's going to be your standard reduced texture sizes, your sprites, your shaders, anything that's memory intensive, as we're seeing in the profiler here. Any of this stuff, these are going to be your big memory consumers. Oh, there we go. Your big memory consumers, so your textures, your message materials, keep the vertices low, manage your geometry if you've got complex objects in there. Objects with a lot of geometry are going to eat up a lot of that memory. And use compressed textures where possible is another best practice for Unity. In my case, I use very small textures, tried to keep them well under a few megabytes. I'm not sure if there's a quick and easy way to go look at those, but I kept them small for all of our graphics. Get this out of the way a little bit here. So if you're looking at the graphics, these are all less than 1024 by 1024, so no more than 2048 is the max size of these objects, and they're relatively small from a compressed JPEG or PNG format on the disk, so that helps to manage the memory quite a bit. And you know, if you can do without any of the fog effects, anything that has high particles that consume a lot of memory and processing power, that's gonna do a lot to manage your memory footprint. But essentially, your textures, your shaders, your audio files that you have to load into memory, as you're seeing from the profiler, my animation clips, things that it. See if I can grab this, drag it up. How am I getting this? There. So all of your audio clips, it loads all this stuff into memory. It loads all of your pre-assets into memory. And this is all just to get it to be able to access those things faster. So as you can see, the animation clips are very tiny. My materials, which I've only got a handful, very tiny. So I use shared materials. They use the same material across a lot of various objects within the game. My meshes are very tiny. So that's really kind of your best practice, and then everything else is just going to be instantiated memory with your application. So that really is going to be the best practices for Unity across the board, whether it's BattleCry or any game. Okay, I hope you've enjoyed taking a look at it. This is the memory profiler for BattleCry. If you have any questions, please don't hesitate to respond in the discussion forum. I'll post this link for the video, and looking forward to hear what you have to say. Thank you.